Okay, so for some reason I didn't go back and renumber my review. Again, this is review 5-1 for Algebra 2, covering the beginning half of Chapter 6. This really should be number 21. This should be number 22. This one down here should be 23. And this one should be 24. So that is how I'm going to refer to them. Just go ahead and make the change on your papers. But that's how I'm going to refer to these 4 problems. But let me go ahead and erase those just to get... Yeah, I'll leave it up there. So what? All right. So number 18, let's graph. First things first, remember, even roots have endpoints. All right, because you cannot take the square root, the 4th root, the 6th root of a negative. Odd roots have inflection points because you can take an odd root of anything. All right, does not matter. So that's the first thing we're going to look for. We've got an even root, so this one has an endpoint. And it is at -2, -4. Okay? -2, -4. So remember, just your transformations. What's being added from the inside, what's being added to the outside. And the inside is backwards. Just your transformations is all that is. From here, we're going to put this in the calculator and get some points. All right, one thing I will say, remember, the easiest way to put a radical in your calculator is to make it a fraction. So the way I put this in was 3x plus 2 to the 1/2. If it was a third root, like number 22 is a third root, I would put it to the 1/3. Okay, so that's what I stuck in my calculator. Anyways, I went to my table and I started and got all the whole numbers. So that's -2, -4, -1, -1. 2, 2, and let's see if we can get one more. If we can get 4 within reason, we'll take it. 7, 5. That comes out nice and pretty. Let's clean up that 7. There we go. 7, 5. Okay? And then we'll graph. And you can make your own graph however you want. My x's, go from -2 to 7, so I'm going to slide over a little bit. My y's go from -4 to 5, so I'm going to put it like that, so I have room to go. And then here we are, -2 to -4, -2, -4, -1, -1, 2, 2, 7, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, right there. And we'll graph it. And there you go. All right, and last but not least for this one, for your domain and range, remember your domain is your x values, your range is your y values. For your x, it starts here at this endpoint and moves to the right. So that's at -2 and goes to infinity. Your range starts here at -4 and goes up. So that goes from -4 to infinity. And always remember to put them in numerical order. Okay? The rest of these work the same way. If I were you, I would try 22, 23, and 24. Give them a shot. Make sure you know how to do them. But I'm just going to burn through them real quick. I'm going to try and do them as fast as possible. Okay. So number 19. Here we go. It is an odd root. It is a third root, so it has an inflection point, and the end point is at -1, 0. It's an inflection point, so I'm going to put it in the middle because I have things on both sides. All right. So. Just to remind you how I stuck in my calculator, I literally typed 3 parentheses x plus 1, and I raised it to the 1/3 power. It is just easier to do that than to find other things. So I graphed it. I put it in my calculator. I got -1, 0. I have -2, -3. I have 0, 3. And let me scan down, see if I get another whole number within reason. Ooh, I got 7, 6. And then I should probably have a negative that's within reason. And -9, -6. So I'm probably going to have to count by 2s on both of those because I go from -9 to 7. I kind of have a wide range. So I'm going to go ahead and mark this. That's a 2. I'm going to count by 2s on this. So -9, -6. 2, 4, 6, 8, 9, 2, 4, 6. -2, -3, -2, -2, 3, -1, 0, -1, 0, 0, 3, 2, 3, that would be right there, and 7, 6, 2, 4, 6, 7's in the middle, 2, 4, 6 is right there, and your graph will look like that. Okay? You'll probably level off a little bit better there in the middle, but that's essentially what it's going to look like. And your domain and range, because it goes both ways forever, left and right forever, and up and down forever, your domain and range for odd numbered roots is always going to be all real numbers. Okay? I'm going to delete this, so pause it if you're still copying. I won't roll, not my home, not my time, and I won't roll. All right. Not 21, 22. The last two, I forgot what I named them. I think 23 and 24. But anyways, this is a cube root, so it has an inflection point, and it is at 0, 1. Okay? 0, 1. And we can already tell you that because it's an odd root, it's going to be all real numbers and odd real numbers. Because remember, odd roots go both ways forever. All right, let me put it in my calculator real quick. All right, and those are your points. Okay? Just, again, stuck in my calculator, got the table, and went from there. And because we go from 16 to 16, I will probably have to count by 4s. X's go from 16 to negative 16, I'm going to count by 4s. So my X's I'll count by 4s, and my Y's I'll count by 2s. Yeah, no, I can count them by 1s. All right, because I got enough room to go 5 up. So here we go. Negative 16, positive 5. 4, 8, 12, 16, 1, 2, 3, 4, 5. Okay. Negative 2, 3. So this is 4, which means that's 2. 1, 2, 3. 0, 1. Positive 2, negative 1. Remember, that's 4, so that's positive 2. And then 16, 3. 4, 8. That should be a negative 3. Sorry. 4, 8, 12, 16, 1, 2, 3. And there you go. There's your graph. Number 21, same idea. It is also an odd root. It's to the 1/5. So it's got an inflection point, and this inflection point is at negative 3, 5. All right. What was I going to say? And you also know, because it's an odd root, we know our domain and range are both, all real numbers. And so I'm going to stick this in my calculator real quick and get some points. And actually, I lied on this one. The inflection point is not negative 3, 5. This is probably not a good question, but we'll just go ahead and work through it real quick. It's because it's good to show you. One of the reasons we typically don't do 2 of these at once inside is because what's really going on there, if I divide out the negative 2, that is a negative 2x to the negative 3 halves. Raise that to the 1/5. So it's being shrunk by negative 2 and shifted by negative 3 halves. Okay, we're not going to give this to you on a test, but hey, it's good to show you. So here we go. Your inflection point is actually at negative 1.5, positive 1.5. 3 halves is 1.5. So positive 1.5, and then your y value is 5. So here we go. 1.55. From here we've got, what's that doing? Oh, put in my calculator. I got 1, 6, and I got 2, 4, and then I think my next whole number isn't until, yeah, something way off the charts. I have no idea where it is. Keep going, keep going. Yeah, I'm at 60. I haven't found one yet. So here we go. We're just going to graph what we got. So 1.5, 5. 1.5, 1, 2, 3, 4, 5. Actually, you know what? I should lower that, because everything is positive y. Let's make that a little cleaner. There we go. 1.5, 1, 2, 3, 4, 5. Not sure how I did that. Then it's 1, 6, and 2, 4. Oh, there we go. So this graph comes in real steep, goes up, and then goes out real steep. Okay? So that's what's going on with that one. I don't think we're going to give you one like that on a test, but hey, it was good to see. Good luck to you.